this lecture, we talk about the self-ionization of water. Water molecule may form hydronium ions with protons donated from other water molecules. The water molecules that donate protons form hydroxide ions, OH-. This process is called self-ionization of water. This is a reversible reaction in water, which is written as two water molecules forms in a hydronium ion and a OH- ion, or one water molecule dissociates into one proton and one OH- ion. But the first equation stands for the true chemical process. Now it's widely accepted. Now, let's write down the equilibrium constant for the self-ionization of water. Kw, W for water, equals the activity of a proton times the activity of OH- divided by the activity of water. The content of a proton and OH- in water is very low. Then the activity value is replaced with the concentration values. And the activity of water, pure liquid, is 1. Then finally, Kw equals the concentration of a proton times the concentration of OH-. Kw looks like as the product of the two concentration values and is called ion product of water. The ion product of water is 10 to minus 14 at 25 degrees C. From convenience, we often use pH value to describe the content of proton in a solution. pH is defined as the minus log proton concentration. Of course, you can also calculate the proton concentration from pH value. Similarly, we can use pOH to describe the content of OH- in the solution. Now let's take logarithm on both sides of the ion product expression. Then we have pKw equals pH plus pOH, and pKw equals 14 at 25 degrees C. In aqueous solution, we often use Bronsted-Lowry definition on acid and base. The acids donate protons, form hydronium ions with water. The bases consume protons, generate OH- ions. When we say the solution is acidic, we mean the concentration of proton is higher than the concentration of OH-. Basic, the concentration of OH- is higher, and the neutral, the two concentration, is equal. But when we talk about if the solution is neutral, we have to consider the effect of temperature. At 50 degrees C, the pKw of water is 13.3, and the pH or pOH value is 6.65. So you cannot conclude that an aqueous solution with pH of 6.9 less than 7 is acidic. It could be basic if at a high temperature. This is because the water has different self-ionization behavior at a different temperature. The ionization or dissociation of acid and base is a process of protonation or deprotonation. For acid, denotes with HA. HA reacts with water, or say, protonates water molecule to produce hydronium ion. An A- ion, as shown in the equation for a base, it also reacts with water. but it deprotonates water molecule to generate BH plus and OH minus. The equilibrium constant expression for acid and base are presented on the right. K with subscript A or B indicates acid or base.